30 incredible fastest big homemade firewood processing machines working. In the world of DIY enthusiasts and mechanical innovators, the quest for efficiency and productivity often leads to remarkable inventions. Among these, homemade firewood processing machines stand tall as testaments to creativity and practical engineering. These machines are crafted with precision and powered by ingenuity, designed to tackle the demanding task of turning raw timber into usable firewood with speed and efficiency. From hydraulic log splitters that exert tremendous force to kinetic splitters driven by flywheels and automated processors that seamlessly cut and split logs, each machine embodies a unique solution to the challenges of wood processing. Built in garages, workshops, and backyard sheds, these creations showcase not only technical prowess but also a deep commitment to sustainable living and self-sufficiency. Join us on a journey through a compilation of 30 incredible homemade firewood processing machines. Discover their diverse designs, innovative features, and the stories behind their creation. Whether built for personal use or shared with a community of like-minded creators, these machines represent the intersection of passion, practicality, and the relentless pursuit of efficiency in woodworking. Get ready to witness the power, precision, and sheer ingenuity of homemade firewood processing machines in action. Each one tells a story of craftsmanship, problem-solving, and the boundless possibilities that come with a passion for DIY engineering. Highlighting 30 incredible homemade machines, especially those focusing on speed and size, can cover a wide range of DIY innovations across various fields. Here's a diverse selection of impressive homemade machines. Number 30. Homemade CNC Router. A homemade CNC router is a versatile machine used for cutting, carving, and engraving various materials under computer numerical control, CNC. These routers are typically constructed with a rigid frame, precise linear guides, a motorized spindle, and a CNC controller. The frame provides stability and support for the moving parts, while the linear guides ensure smooth and accurate movement of the cutting tools. The motorized spindle rotates cutting tools such as end mills, router bits, or engraving tools, allowing the machine to perform intricate operations on materials like wood, plastic, aluminum, and even some types of metal. DIY enthusiasts often customize their CNC routers with features such as adjustable speeds, tool changers, dust collection systems, and touch probes for automatic tool height adjustment or material calibration. These machines are widely used in woodworking, signage making, prototyping, and small-scale manufacturing due to their ability to automate complex cutting tasks with high precision and repeatability. Building a homemade CNC router requires knowledge of mechanical assembly, electronics, and programming. It offers enthusiasts the opportunity to create custom designs, optimize functionality, and explore the capabilities of CNC technology in digital fabrication and manufacturing. Number 29. DIY Electric Go-Kart. A DIY electric go-kart is a customized electric vehicle built for recreational or competitive racing purposes. These projects typically involve converting a traditional go-kart chassis or building one from scratch to accommodate an electric motor, battery pack, and electronic controls. Builders often select components like high-torque electric motors, lithium-ion batteries for extended range, and controllers for regulating speed and acceleration. Customization options include adding safety features like roll cages, harnesses, and braking systems for enhanced control and safety on the track. DIY electric go-karts are popular among enthusiasts for their performance, eco-friendliness, and the opportunity to explore electric vehicle technology in a fun and hands-on manner. They demonstrate innovation in sustainable transportation solutions and showcase the intersection of engineering, design, and recreational sports. Number 28. Hydraulic Press Brake. A hydraulic press brake is a machine tool used for bending sheet metal into desired shapes and angles. It operates by applying force through hydraulic cylinders to a punch and die set, which forms the metal between them. Typically consisting of a sturdy frame, hydraulic system, and a control panel, press brakes can handle various thicknesses of metal sheets and offer precise control over bending angles and dimensions. DIY enthusiasts and small workshops often use hydraulic press brakes for fabricating components, panels, and enclosures in metalworking projects. These machines are essential for achieving accurate bends in sheet metal, allowing for customization and production of parts with consistent quality and precision. Number 27. Large-Scale 3D Printer. A large-scale 3D printer is an advanced additive manufacturing device capable of creating large objects or components with dimensions exceeding those of standard desktop 3D printers. These machines use techniques such as fused deposition modeling, FDM, stereolithography, SLA, or selective laser sintering, SLS, to build layers of material, typically plastics, resins, or metals, based on digital 3D models. Constructed with robust frames, precise linear motion systems, and high-capacity extruders or resin tanks, large-scale 3D printers are used in industries such as aerospace, automotive, architecture, and manufacturing for producing prototypes, custom parts, and even entire structures like buildings or vehicle components. DI enthusiasts and businesses alike can benefit from their capability to create complex geometries and functional prototypes efficiently, pushing the boundaries of design and production capabilities. Number 26. Wood chipper/shredder. A wood chipper/shredder is a powerful machine used to reduce branches, twigs, and other yard waste into smaller pieces or chips. Typically powered by a gas engine or electric motor, these machines feature a hopper for feeding materials and a rotating blade or cutting mechanism that chops them into manageable pieces. These machines vary in size and capacity, offering efficient disposal of yard debris and promoting sustainability through recycling organic materials back into the ecosystem. Number 25. DIY CNC Plasma Cutter. DIY CNC Plasma Cutter is a computer-controlled cutting machine that uses a plasma torch to cut through electrically conductive materials such as steel, aluminum, and copper. Constructed with a sturdy frame, a plasma torch mounted on a CNC-controlled gantry, and a CNC controller with software, these machines cut precise shapes and designs by generating a plasma ore that melts the material and expels molten metal through the cutting path. DI enthusiasts often build plasma cutters using materials like steel tubing, linear guides for movement, and a plasma power supply. These machines are used for fabrication, metal artwork, and custom metalwork projects, offering high-speed cutting with minimal heat-affected zones compared to traditional methods. Number 24. Homemade electric bicycle. A homemade electric bicycle is a custom-built bicycle that incorporates an electric motor and battery to assist with pedaling or provide full electric propulsion. Typically constructed with a standard bicycle frame, a hub motor or mid-drive motor, lithium-ion batteries, and a controller, these bikes offer enhanced speed and range compared to traditional bicycles. DI enthusiasts often customize their electric bicycles with features like pedal assist sensors, throttle controls, regenerative braking systems, and LED displays for monitoring speed and battery level. These projects promote eco-friendly transportation solutions and showcase innovation in combining cycling with electric propulsion for commuting or recreational purposes. Number 23. DI bandsaw mill. A DI bandsaw mill is a versatile woodworking tool designed to cut logs into lumber using a rotating bandsaw blade. Typically built with a sturdy frame, a motorized bandsaw blade, and adjustable cutting guides, these mills are used for milling logs into boards and beams with precision and efficiency. DI enthusiasts often construct bandsaw mills using steel or aluminum components, incorporating features like adjustable blade tension, blade guides, and a log loading and turning mechanism. These projects enable woodworkers to process raw timber into custom-sized lumber for woodworking projects, furniture making, and construction, demonstrating innovation in self-sufficient and sustainable lumber production. Number 22. Homemade CNC laser cutter/engraver. A homemade CNC laser cutter/engraver represents a pinnacle of DIY innovation, combining precision cutting and engraving capabilities with the flexibility of computer numerical control, CNC. These machines are typically built with sturdy frames, high-powered laser modules, precise linear guides, and controlled by a CNC system. Enthusiasts customize these machines with features such as adjustable laser power, variable cutting speeds, and compatibility with a wide range of materials including wood, acrylic, leather, and metal. This versatility allows for the creation of intricate designs, signage, prototypes, and personalized items with high accuracy and detail. Homemade CNC laser cutters/engravers not only empower individuals and small businesses to produce custom creations, but also foster creativity and exploration in digital fabrication. They exemplify the intersection of technology and craftsmanship, enabling users to push the boundaries of what's possible in laser cutting and engraving, all from the comfort of a DIY workshop. Number 21. DIY hydraulic excavator. Building a DIY hydraulic excavator is a challenging yet rewarding project that showcases advanced engineering and mechanical skills. Typically constructed from robust materials like steel, these excavators feature hydraulic systems that power the movement of the boom, bucket, and tracks or wheels. DIY enthusiasts often integrate components such as hydraulic cylinders, pumps, valves, and a control system to mimic the functionality of commercial excavators. The project involves careful planning of the excavator's structure and hydraulic circuitry, ensuring safety and efficiency in operation. Builders customize their designs based on excavation needs, adding features like adjustable boom angles, bucket attachments, and ergonomic operator controls. A homemade hydraulic excavator serves as an educational endeavor, providing insights into fluid power systems, mechanical design, and heavy equipment operation. While ambitious in scope, it exemplifies innovation in construction equipment technology and showcases the capabilities of DIY enthusiasts to create functional machinery for practical applications. Number 20. Custom off-road vehicle. A custom off-road vehicle is a specialized vehicle modified for rugged terrain and challenging environments. Built with enhanced suspension, durable tires, and often featuring reinforced chassis and additional equipment like winches and protective gear. These vehicles are designed for off-road adventures, such as rock crawling, desert racing, or overlanding. Enthusiasts customize these vehicles to optimize performance and reliability, reflecting their individual preferences and technical expertise in off-road vehicle engineering. Number 19. Homemade jet engine. A homemade jet engine is a complex propulsion device designed to generate thrust by compressing air, mixing it with fuel, and igniting the mixture to produce high-speed exhaust gases. Typically built with components like a compressor, combustion chamber, turbine, and nozzle, these engines operate on the principle of continuous combustion and expansion of gases to create thrust. While challenging to build and optimize for efficiency, homemade jet engines serve as educational projects to explore aerodynamics, combustion engineering, and turbine mechanics, showcasing innovation in aerospace technology at a smaller scale. Number 18. DIY hydroelectric generator. A DIY hydroelectric generator is a renewable energy system designed to harness the power of flowing water to generate electricity. Typically constructed with components like a water wheel or turbine, a generator and transmission system. These generators convert the kinetic energy of water into electrical energy. DIY enthusiasts often build these generators using materials like PVC pipes, recycled materials, and small-scale generators or alternators. They can be customized for different water flow rates and head pressures, making them suitable for small streams, creeks, or even backyard water features. DIY hydroelectric generators promote sustainability by providing clean, off-grid electricity for remote locations, or as an educational project demonstrating renewable energy principles. Number 17. Homemade CNC milling machine. A homemade CNC milling machine is a versatile tool used for precision machining of various materials under computer numerical control. CNC. Typically built with a rigid frame, precision linear guides, a motorized spindle, and a CNC controller. These machines can carve, drill, and cut intricate designs in materials like wood, metal, and plastics. DIY enthusiasts often customize their CNC milling machines with features such as adjustable speeds, tool changers, and coolant systems to optimize performance for specific projects. These machines are essential for prototyping, custom part manufacturing, and educational purposes, offering precise and automated machining capabilities in a compact and affordable setup. Number 16. DIY robot arm. A DIY robot arm is a mechanical arm designed and built by enthusiasts to mimic the functions of a human arm or perform specific tasks autonomously. Typically constructed with servos or stepper motors for each joint, along with rigid materials like aluminum or 3D printed parts. These arms are controlled by microcontrollers, such as Arduino or Raspberry Pi. They feature grippers or specialized end effectors for tasks like picking and placing objects, assembly line operations, or educational demonstrations. DIY robot arms often incorporate sensors for feedback and precise movement control, allowing for programming of sequences or responding to environmental stimuli. These projects encourage learning in robotics, automation, and mechanical engineering, showcasing innovation in designing functional and affordable robotic systems. Number 15. Homemade rocket stove. A homemade rocket stove is a highly efficient cooking or heating stove designed to burn small pieces of wood or biomass cleanly and with minimal smoke. Constructed from materials like metal cans, bricks, or steel tubing, these stoves feature a combustion chamber with a vertical chimney or insulated combustion chamber that directs airflow for efficient combustion. The design creates a strong draft that pulls air into the stove, ensuring complete combustion of fuel and maximizing heat output. Rocket stoves are popular for outdoor cooking, camping, and emergency preparedness due to their fuel efficiency and portability. DIY enthusiasts often customize rocket stoves with features like pot stands, heat shields, and ash collectors to enhance usability and safety. Number 14. DIY CNC router table. A DIY CNC router table is a versatile tool used for automated cutting, carving, and machining of various materials under computer numerical control, CNC. It typically consists of a sturdy frame, precision linear guides, a motorized spindle, and a CNC controller board. The router table is equipped with a flat bed where the material to be machined is securely mounted. The CNC system controls the movement of the spindle and cutting tools along multiple axes, allowing for precise and intricate designs to be created in wood, plastic, aluminum, and other materials. DIY enthusiasts often customize their CNC router tables with features such as variable speed control, dust collection systems, and interchangeable tool holders to suit different machining tasks. These machines are used in woodworking, prototyping, and small-scale manufacturing, offering efficient and accurate production capabilities for a wide range of projects. Number 13. Homemade electric skateboard. A homemade electric skateboard is a personalized transportation device, combining a traditional skateboard deck with an electric motor and battery pack for propulsion. Typically built with components like a motorized wheel hub or belt drive system, lithium-ion batteries, and a handheld wireless remote for speed and braking control, these skateboards offer enhanced speed and range compared to manual skateboards. DIY enthusiasts often customize their designs with features like regenerative braking, adjustable speed settings, and durable materials for the deck and enclosure. These projects cater to urban commuters and enthusiasts seeking eco-friendly, versatile transportation options, showcasing innovation in electric vehicle technology at a smaller scale. Number 12. DIY solar tracker. A DIY solar tracker is a mechanism designed to orient solar panels or photovoltaic arrays toward the sun throughout the day, optimizing their efficiency in capturing solar energy. These trackers typically use sensors or algorithms to detect the sun's position and adjust the orientation of the solar panels accordingly. The mechanism may employ actuators, motors, or hydraulic systems to tilt and rotate the panels, maximizing exposure to sunlight and enhancing energy output by up to 25% compared to fixed installations. DIY enthusiasts often build solar trackers using Arduino or Raspberry Pi controllers for automation, along with sturdy materials like steel or aluminum for the frame and tracking mechanism. These projects promote renewable energy adoption by improving solar panel efficiency, making them suitable for residential, agricultural, or small-scale commercial applications, where maximizing solar energy yield is crucial. Number 11. Home-built wind turbine. A home-built wind turbine is a renewable energy system designed to harness wind power and convert it into electricity. Typically constructed with a sturdy tower, rotor blades, a nacelle, housing the generator and gearbox, and a tail or yaw system. These turbines operate by capturing wind energy to rotate the blades. The rotational energy drives a generator, converting mechanical energy into electrical power. DIY enthusiasts often use materials like steel or aluminum for the tower, fiberglass or carbon fiber for the blades, and a suitable generator depending on the desired power output. Home-built wind turbines can be tailored to local wind conditions and energy needs, providing sustainable electricity for off-grid applications, reducing reliance on fossil fuels, and showcasing innovative approaches to renewable energy generation. Number 10. DIY CNC wire bender. A DIY CNC wire bender is a sophisticated machine designed to automate the bending of wire into precise shapes and patterns using computer numerical control. CNC, constructed with a sturdy frame, motorized wire feeding system, and a precision bending head controlled by servo or stepper motors. It operates by feeding wire through the bending head, which shapes it according to programmed instructions. This customization allows for the production of intricate wire components with high accuracy, making it suitable for applications in electronics, custom fabrication, and various industries requiring precise wire forming capabilities. DI enthusiasts often build and customize these machines to enhance productivity and expand their skills in CNC automation and manufacturing. Number 9. Homemade CNC lathe. A homemade CNC lathe is a precision machining tool controlled by computer numerical control, CNC, used for shaping cylindrical workpieces, constructed with a sturdy frame and precise components like stepper motors and linear guides. It features a motorized spindle that rotates the workpiece. The CNC system guides the cutting tools mounted on a tool post, enabling operations such as turning, facing, and threading with high accuracy. DI enthusiasts often customize their lathes with variable speed control, automatic tool changers, and digital readouts, making them versatile for prototyping, custom part manufacturing, and educational projects. These machines demonstrate advanced manufacturing capabilities and offer practical insights into CNC machining principles, enhancing skills in precision engineering and fabrication. Number 8. DI vacuum forming machine. A DI vacuum forming machine is a versatile device used to create molds and replicate intricate shapes by heating thermoplastic sheets and forming them over molds using vacuum pressure. Typically constructed from a sturdy frame, heating elements such as ceramic heaters or nichrome wire, and a vacuum pump, these machines work by heating a thermoplastic sheet until it becomes pliable. The heated sheet is then positioned over a mold or pattern on a perforated platen. As the vacuum pump draws air through the perforations, it pulls the softened plastic tightly against the mold, forming a precise replica of its shape. DI enthusiasts often build and customize vacuum formers to suit specific project needs, incorporating features like adjustable heating controls, timers, and vacuum pressure gauges. This customization allows for molding various materials and achieving different levels of detail and complexity in the finished products. Vacuum forming machines find applications in prototyping, small-scale manufacturing, cosplay prop making, custom packaging, and hobbyist model crafting, offering a cost-effective and accessible way to produce high-quality custom-formed parts and prototypes. Number 7. Homemade wood lathe. A homemade wood lathe is a versatile machine designed for turning cylindrical or rounded shapes from wood. It typically consists of a sturdy bed or frame, a motorized spindle, and a tool rest that supports cutting tools. The spindle rotates the workpiece at various speeds, controlled by a motor with adjustable pulleys or electronic speed control. DI enthusiasts often build wood lathes using materials like steel tubing for the frame, bearings for smooth rotation, and a variety of motors depending on the desired torque and speed range. The tool rest is adjustable to accommodate different workpiece sizes and shapes, allowing for precise shaping and smoothing of wood surfaces. Home-built wood lathes can be tailored with additional features such as variable speed control, indexing mechanisms for creating symmetrical designs, and custom tool holders for different cutting tools. These machines are essential for woodworking projects ranging from crafting furniture legs and bowls to creating decorative pieces, demonstrating craftsmanship and precision in turning wood into intricate and functional objects. Number 6. DIY CNC Wire EDM Machine. A DIY CNC Wire EDM, electrical discharge machining, machine is a sophisticated tool used for precision cutting of conductive materials using electrical discharge sparks. Unlike traditional cutting methods, EDM machines utilize a controlled electrical discharge between a thin, continuously fed wire electrode and the workpiece to erode material with extreme accuracy. Here's a detailed look at its functionality. Constructing a DIY CNC wire EDM machine involves assembling a robust framework, typically made from steel or aluminum, equipped with precision linear guides and servo motors for precise wire movement. The heart of the machine is its CNC control system, which coordinates the positioning of the wire electrode and controls the intensity and duration of electrical discharges. During operation, the wire electrode, often made of brass or tungsten, is fed through the workpiece while submerged in a dielectric fluid that flushes away debris and controls the sparking process. This controlled sparking creates precise cuts with minimal heat-affected zones, making EDM ideal for machining intricate shapes and hardened materials that are challenging to cut with conventional tools. DI enthusiasts and machinists often build these machines for prototyping, toolmaking, and small batch production. Customizing parameters such as discharge voltage, pulse duration, and wire feed rate to optimize cutting performance for specific materials and applications. While complex to construct, DIY CNC wire EDM machines offer unparalleled accuracy and versatility in machining conductive materials, demonstrating advanced manufacturing capabilities accessible to skilled hobbyists and small-scale workshops alike. Number 5. Custom hovercraft. A custom hovercraft is a unique vehicle that operates on a cushion of air, allowing it to glide smoothly over various surfaces, including water, land, mud, and ice. These vehicles are characterized by their ability to hover above the ground, propelled by fans or propellers that create and maintain the air cushion. The design typically includes a lightweight hull or platform, often made from fiberglass or composite materials, equipped with one or more engines to drive the lift and thrust systems. Steering and control are achieved through rudders, vanes, or directional thrust adjustments, providing maneuverability in different terrains. DI enthusiasts and engineers often customize hovercraft designs to suit specific purposes, such as recreational use, search and rescue operations, or scientific exploration in remote or difficult-to-access areas. Building a custom hovercraft involves integrating propulsion systems, ensuring buoyancy and stability, and optimizing airflow dynamics to achieve efficient hovering and maneuvering capabilities across diverse environments. These projects exemplify innovation and creativity in vehicle design, blending elements of aerospace engineering with marine and terrestrial mobility solutions. Number 4. Homemade CNC foam cutter. A homemade CNC foam cutter is a precision tool designed for cutting and shaping foam materials with accuracy and efficiency. Typically built using stepper motors, aluminum extrusions, and a hot wire or blade assembly. These machines are controlled via computer numerical control, CNC, software. The hot wire or blade moves along multiple axes, guided by the CNC system, allowing for intricate designs and precise cuts in foam sheets or blocks. DI enthusiasts often customize their foam cutters with adjustable cutting depths, variable wire tension systems, and interchangeable cutting tools to accommodate different foam densities and project requirements. These machines find applications in various industries such as model making, prototyping, insulation manufacturing, and artistic installations, providing cost-effective solutions for producing complex foam shapes with repeatability and high accuracy. Number 3. DIY Pulse Jet Engine. A DIY pulse jet engine is a fascinating and experimental project in aerospace engineering, known for its simplicity and unique operational principles. Unlike traditional jet engines that rely on continuous combustion, here's a detailed paragraph on its workings. A DIY pulse jet engine represents a pinnacle of engineering curiosity and innovation, characterized by its straightforward yet dynamic design. Constructed primarily from metal tubing, a combustion chamber, and a few basic components, the engine harnesses the power of pulsating combustion to generate thrust. This expulsion of gases creates thrust in the opposite direction, propelling the engine forward. The cycle of intake, combustion, and exhaust repeats in rapid succession, producing the distinctive buzzing sound associated with pulse jets. Propulsion systems, or educational demonstrations. While challenging to optimize for efficiency and stability, successful DIY builds offer valuable insights into combustion dynamics and the principles of jet propulsion, fostering innovation and understanding within the aerospace community. Number 2. Homemade biodiesel processor. A homemade biodiesel processor is a specialized device used to produce biodiesel fuel from vegetable oils, animal fats, or recycled cooking oils through a chemical process known as transesterification. Here's a detailed paragraph on its workings. A homemade biodiesel processor is an essential tool for eco-conscious individuals seeking to reduce their carbon footprint and reliance on fossil fuels. Typically constructed using basic equipment such as stainless steel tanks, heating elements, and mixing chambers, these processors facilitate the conversion of oils into biodiesel through a series of chemical reactions. The process involves heating the oil to a specific temperature and mixing it with an alcohol, usually methanol or ethanol, and a catalyst, typically sodium hydroxide or potassium hydroxide. This mixture triggers transesterification, where glycerin separates from the biodiesel. After settling and filtering, the resulting biodiesel undergoes washing to remove impurities before being ready for use in diesel engines. DI enthusiasts often customize their processors to enhance efficiency and safety, incorporating features like automated mixing controls and safety measures to manage potentially hazardous chemicals. By producing biodiesel locally, these homemade processors not only promote sustainability but also offer a cost-effective alternative to conventional diesel fuels, supporting greener energy practices on a smaller scale. Number 1. DIY Vertical Axis Wind Turbine. A DIY vertical axis wind turbine (VAWT) is a fascinating endeavor in renewable energy innovation. Distinct from traditional horizontal axis turbines, unlike their horizontal counterparts, VAWTs feature blades that rotate around a vertical axis, resembling a rotating helix or egg beater. This design offers several advantages. Firstly, VAWTs are omnidirectional, meaning they can capture wind from any direction without the need for a yaw mechanism to turn into the wind. This flexibility makes them particularly suitable for urban environments where wind patterns are unpredictable. Moreover, their lower height and compact design make them easier to install and maintain, often requiring less space than HAWTs. DIY enthusiasts embarking on building a VAWT typically use a variety of materials such as PVC pipes, aluminum tubing, or even recycled materials for the blades and frame. The construction process involves designing a sturdy base, crafting aerodynamically optimized blades, and integrating a generator or alternator to convert wind energy into electrical power. Successful DIY projects often emphasize efficiency improvements and adaptation to local wind conditions, showcasing ingenuity and commitment to sustainable energy solutions at a grassroots level. Conclusion. In conclusion, the realm of homemade firewood processing machines showcases remarkable ingenuity and innovation among DIY enthusiasts and small-scale manufacturers alike. These machines, ranging from powerful log splitters to efficient firewood processors, demonstrate the ability to harness creativity and engineering skills to streamline wood processing tasks. With designs tailored to optimize speed, efficiency, and safety, these homemade machines not only meet practical needs, but also inspire a community dedicated to sustainable forestry practices and resource utilization. Whether for personal use, small businesses, or community projects, these homemade firewood processing machines exemplify the spirit of craftsmanship and problem-solving, driving advancements in wood processing technology at the grassroots level. Thanks for watching. Don't forget to like and subscribe to our YouTube channel.